again, welcome to ZenView Studios Lab. This is a video about modification that I did on a Rotel RA-840BX4. The purpose was to try to get the channel not to overheat as it was after the repair. That was the initial purpose, and eventually it led to an improvement of the THD, which came down 11 dB thanks to the mod. The mod I found on Do-It-Yourself Audio. I'll go over the schematic that was on Do-It-Yourself Audio, and what I did, my take on the mod, because the schematic, the modification was intended for a 820 model, and we are talking about an 840 model. Although it said it could be applied to any model, it's not. You had to do some changes to get where we got. So here we go. Let's go directly to the schematic to see the mod. So this is the part with the schematic where which is taken from Do-It-Yourself Audio. I will give you the link in the video description, and this is what the schematic says. Change a certain number of resistors or different places. In fact, this schematic you will see if you compare to your 840 is not exactly the same. It's the one from the 820. Now the first thing was, as I said, the reason why I did the change was to get rid of overheating of the transistors here and the resistors, even though they were 3 watts. So in this mod, you take off the two 1K resistors, very simply. You take them off away. And you join the emitter of both transistors here with a 82 ohm resistor. That's what's supposed to be. I can zoom in to show you a little bit if you prefer. Voila. This is the schematic that, and I will show you on the board itself where that comes in. Okay, if we look at the board, we can see that I've replaced the resistor here. It's joining those two emitters from one side of the resistor to the other side here. Okay, and that's this is my take on an 82. It's exactly 82 ohms measured. So that's how I got, because I didn't have an 82 ohm resistor, so I made one. So you take off just those resistor here, the 1K, and you put between the two emitter that 82 ohm resistor. When you do that, the two transistors here don't overheat anymore. The current is much lower in here, so this will not overheat. And the whole stage becomes, in fact, thermally very good. You don't have problems like you might have had with the other design. So, in fact, as far as thermal things go, this would be enough. Now, the mod that was given does a lot more than that, and the rest, I will zoom a little bit out. The rest is done to improve really on THD. The things that they say is you should modify those two resistors here, and also those two here, and take away the cap. And they talk about also these two resistors and this resistor. However, I don't recommend, in fact, I will tell you, don't change those two resistors. They're 1.8K. They should stay 1.8K. The reason is that if you do change to 1K, I tried, you will limit the voltage swing at the output, and you'll clip before full power is reached, because it was for an 820, not for an 840. So probably the other guy could not see that. Here on, however, on the 840, if you should remain with those two resistors. However, if you do change those for 270s here, 10K, 10K, and take off the cap, you will improve THD. You will improve by 11 dB, in fact, THD overall. And that's great. That's better than great. It's very good. This resistor, however, should not be shorted. It's the feedback resistor. It should remain as 120K. It works much better with that as such. I tried both and came back to the original. So again, just two resistors here, two resistors there, take off the cap. That's enough to, with the rest of the mod for the overheatings, that's taking off 1K here and putting one little quarter watt 82 ohm resistor here, and you're done. And you change the amp THD behavior from -70 to -81. I will show you on the spectrum analyzer the results. I took care of not changing both channels so we could compare results and specs between modified and non-modified until I finish, obviously. I will eventually modify the second one too. But that was part of the test and how you get to better specs. So this is what you see here. In fact, you have new resistors here, there, couple of places. So those four resistors, two taken away. There's a cap here missing. That's exactly it. And this resistance is the one that shouldn't be shorted. The others two, as I detailed, you don't change. Fairly simple, and the result is great. In fact, the result is as good, as I said in a previous video, as the THD of a competitor of 20 years later, which is the NAT 326, which has a -81 THD spec. And this Rotel then becomes a contender with that mod. You have now, once you make the mod, you get an amp that in fact powers out 57 watts or so. And that's actually like at least 17 watts more than the NAD, and with the same spec. Voila, so it's not that bad. It's actually quite good. And changes that category of amp, I would say. Let's go to the spectrum analyzer. So this is the result with the Rotel amplifier. You can see we have about 11 dB at power level, and it's been running for a while. So that's with about a little bit less than 12 watts, which is about the maximum that my probes allow me to run the spectrum analyzer at. So what you can see is the difference between the modified channel and the non-modified channel, and I will go over the modification on the schematic that I did, so you can follow. This is for the 840. The proposed modification was for the 820, and I modified that to fit the 840 and tested. And we get about minimum is 11 dB difference between both channels. It gets to 12, 13 at lower power levels. That's already quite outstanding result for such an era amplifier. So here are the specs.